did that. Homeostasis now. Interesting. So I'll try to explain it. Okay. So we have Hunter. Hunter just got in a car accident. And what just happened? He's losing blood, right? So when you lose blood, you're also losing pressure in your body. Just like an oxygen tank, if you take all the oxygen out, there's really not a lot of pressure in there anymore. So you're losing blood. And I can't write anymore. You're losing blood, so your blood pressure is also dropping. Okay, and so here we have set point, right? It's the pressure that we want his body to be at. And it's okay if it fluctuates within normal range. His body's going to do that anyways when he exercises, when he rests, different things of that sort. So now we have this incident occur. So what is it? Further to the right is blood loss or pressure?
The y-axis represents liters of blood loss, and x represents the heart rate.
Okay. So they gave us this chart representing blood loss and heart rate. Why would his heart rate change?
Since there's less blood, it's going to try to pump harder. Get more blood to the organ.
The medulla oblongata
Yeah.
is just on the brainstem, and it is pretty much in check with all the vitals of the human body. And so it notices a change in temperature or a change in blood pressure, and it's going to send a signal back down to the heart. Is it afferent or efferent signal? Efferent, right? E is exiting, so it's exiting the control center. Sends the efferent message back down to the heart and says, you got to speed up. Things are not looking good for you right now. And so that's what Hunter's heart's doing right here. It's saying, okay, I'm going to have to kick it up if I want to save his body. The body really doesn't recognize that it's losing blood, though. That's kind of a bad thing. But the heart did start picking up, right? And that's where it's saying that it's going to be negative feedback. That's the reason why it says it, but okay. I like your argument a lot better. You are seeing positive feedback right here.
But the heart rate is the negative feedback.
Yeah, in a way. It's really, in the end, it's going to be negative feedback, though.
Okay.
Or positive feedback, sorry. It will be positive feedback because if he continues to bleed and his heart rate continues to increase, he's going to pump blood out even quicker and quicker and quicker to the point where you die from loss of blood, right? So that question's tricky.
Okay.
But you could see something like that on the test. It may give you like two variables like that and say, and it will focus on the one like your blood pressure seeing positive or negative feedback.
In this case?
Yeah, what would the blood pressure do at first?
It would be negative feedback.
It'd be negative feedback at first, right? But later, it'd be positive feedback. Yeah. I know a lot of the teachers just kind of, they use those questions that they were going to use on the test, but they realized, oh, it's not a good question, or it's not going to make them think the way we want them to think. Yeah. And so they'll use them on some of the practice questions. So some of those questions really aren't the best, and they know it, and that's why they kind of gave it to you as something to practice on. Okay. Because if you could figure out the problems with those questions, then you're going to be even better for the test. Right. Even though they're not the greatest questions. But does this make sense?
Yeah.
Mm-hmm.
Yeah.
So I just have a quick question about receptor, control center, effector. So in that case, the receptor would be the medulla oblongata, right? Because it's recognizing that there's something up.
Yeah.
And then the effector would be the heart, because it's like pumping blood and trying to...
Causes an effect, right?
Yeah. And then the control center... I guess, what's the control center?
It's the brain also, brain and spinal cord.
Okay.
For almost all of them, it's brain and spinal cord.
Mm-hmm.
I know they say look for the control center for different scenarios of their body, but like 99% of the time it's going to be brain and spinal cord.
Yeah.
Because
Okay, so the receptor, like, is it...
it's what notices the change.
Yeah. So
Or what senses the change. So if
Yes, the medulla.
Your receptor, if you touch something really hot,
Okay.
what would it be?
The receptor?
Yeah, what would the receptor be? If I touch something hot, my body says,
Well,
oh
just
no.
like the burn on your hand, like you notice.
It'd be all the nerves in your hand, right?
Yeah.
That's what's sensing the change.
Yeah.
So the receptor is whatever receives notice of the change.
Okay.
So in this sense, your nerves wouldn't feel that there's less pressure. It'd be the medulla oblongata in the brain.
Okay.
Yeah. Cool. Did that clarify your questions?
Yeah.
Okay. You have any questions, Liza? You've been quiet.
I actually do. So
Yeah.
like he gave this example and I can't remember now. I'm confused what it like he meant by it. But like when you go to the doctor and they like hit your knee or whatever and you have like a reaction, is that from it's not from your brain being the control center, is it? It's like
Yeah, so that's a reflex. So that would actually be through the spinal cord.
okay.
Yeah, because your reflexes never really reach your brain. I mean, maybe at some point they do, but rather this is going to cause tension on the tendon, which then causes a certain organ in your leg or in your tendons to react, or your muscle spindles to tighten up, and so they'll contract. And so it's just checking the nerves that go into your spinal cord and back down to your leg.
Okay, cool.
So, yeah, kind of interesting. So yeah, I guess the control center for that again would be spinal cord.
Okay.
It wouldn't really reach the brain though.
Okay.
Yeah.